checking the distance from the centre of the spindle to the end of the shaft. The neons should light. We'll check. I'm inching along now, 1/100th of a millimetre at a time, towards the job. And the LEDs have illuminated, which informs me that the edge finder is now touching the end of the shaft. So what we have to do now is to move away from the job, set the x-axis to 0, and move in the direction of the part half of the indicator diameter, which in this case is 2.5 millimeters. It's a 5 millimeter diameter shank on the end of the edge finder, and then set the 0 on the x-axis. Move away now to remove the edge finder, move it away to a safe height, remove the edge finder. Now we have to check that the part is parallel with the table to make sure that these holes are actually horizontal. You can do that with two means. There's a flat machine on here which is in line with the holes, so we put a small bubble level on that, and that indicates that it's absolutely 0. With a further check we can do it with the old-fashioned method, by eye. By eyeball, that is in the centre. So we're happy with that. Put the instruments back, ready for the next job. Fit tool number 1, which is a 3 millimeter spotting drill. It's ground at 120 degrees. We now need to set that so that it's 1 mil from the surface, 1 millimeter from the surface that we're going to work on. That's a 1 millimeter slip. Just passes. So we now know that that tool is 1 millimeter off the surface of the work. So take the x-axis back to 0 again. 0 the z-axis, the z-axis. If you're an American you'll be saying Z. Switch the machine back to CNC mode. Switch the motor control switch to the CNC position. Move the collector, surge collector into position. Put some air on. Put a little bit of mist onto it. Close the door. And press the program start. Set the speed of the spindle, 1400. Press the start. Now I'm going to spot the first hole position. It's now going to spot the second hole position. It moves away now for a tool change. So we need tool number 2. .9mm drill. It's now going to drill through the complete shaft. It's only drilling at a very low rate of knots, because the first test piece that I did, I had a problem with the drill breakage. It couldn't cope with the tougher aluminium, not at the feed I was giving it, so I've reduced the feed right back. I haven't upped the speed so much because I like to see that the drill is cutting, not just bringing flakes out. Even at that speed there's nothing, no great pieces of swarf coming away, but it's slow and sure. I'm not on piecework. This is just for a model. Quite a large one, but it's just for a model. It's going to be operating an all movable tail. The reason for the billeting of the material, where the arms join the centre. The material is 7075 T6 aluminium, recognised as being one of the strongest aluminium. It was specified for this job. It's the reaming complete. Now it wants a tool change again. This is all tool changes, this job. Next tool is a 3mm reamer. Machine reamer. It's not tapered, it's parallel. Parallel all the way. Press the start, program start again, continue. Take the revs back a bit for that. You don't want to hoss them through there. 1500. set the revs back to 700. Should be happy doing a reamer and reaming operation at that speed. If I hear the motor labouring slightly, I'll up the revs. It's in a reaming cycle now, G85, so it goes down into the hole at a controlled speed and it stops and then returns at the same controlled speed. It's not like a drilling function where it goes in at a slow speed and out rapid. It drives in a controlled attitude and returns at the same speed. You can insert a dril if you want at the bottom, but as we're passing through completely through the reamed holes, there's not any need for a dril. Now needs another tool change. I cheated there because I didn't have an M in after the tool change, so there wasn't enough room to get the tool in, so I moved it up to the next line. It's now going to come down 25 mil. Now you're going to drill the second hole. Just going to stop at drilling for the moment. I want to insert a bolt into this first hole, just to make sure it doesn't move, because I want these two holes completely in line. You can see it's a fairly slow operation. No need to rush these things. Quite a few hard work in those parts. There's no point in spoiling them, just to rush a hole through. Back for a tool change. Turn the revs down a little bit, 700, press the start button again and away we go. You can use a hand reamer on this if you need. But the hand reamer's got a tapered nose, so you have to pass it much further through the part to get to a fully parallel section. Sometimes it's useful to have a hand reamer and not take it all the way through. Leave part of the tapered cutting section within the hole, so that when you drive a suitable size pin in, it will be a push fit at the start of the hole, but at the end of the hole it will be pinched up, so you'll need to tap it in, so it gives you a secure fixing. I'm going to stop the machine very shortly. As soon as that reamer gets out. In fact, I'm going to stop it before it gets out. Remove this bolt. Otherwise, when that reamer comes out and goes back to the starting position, it wouldn't have cleared the head of the screw, I don't think, just in case. I think it only comes out to 1 mil clear before it goes back to the start position. Yeah. Good job I took the bolt out. Turn the little compressor off. Pop the bolt back in. We release the chuck. Before that, I'll say that if the part is going to need some heat to get it off. Just going to clean these tops, so that will indicate to me that they were at the top as the shaft as I was doing the drilling. I'll also put a couple of marks on it. We'll use the magic marker. See the part? That's it. Thanks for watching. See the tools on the top were the ones that we used. Spotting drill, the 2.8 or 2.9 drill, and then the reamer. For tools number 1, 2 and 3. And the Emco.